The culmination of decades of innovation has led to the recent arrival of the Perseverance rover on the surface of Mars. But there has been a specific innovation that carries much of the burden. You may be holding a device with millions, even billions of these atomically small semiconductors without even realizing how revolutionary such tech was. First constructed in 1947 by John Bardeen and Walter Brising at Bell Labs, the transistor is a semiconductor device that amplifies or switches electronic signals or electrical power. Constructed usually with silicon and sometimes with germanium, they can act as switches or amplifiers. This is a scaled-up example of a FinFET transistor, whose main components are a silicon fin that makes up the source and drain, and an electric gate that wraps around it. The way this works is that the FinFET transistor triggers an output current by the drain when certain voltage, in this case 0.7 volts, is fed through the gate by the source. This is how binary numbers are generated in electronics. You usually get a 1 when a transistor is giving an output and 0 when it isn't. Combining millions or billions of these small semiconductors allow for a wide range of operations, from simple arithmetic operations to autonomous spacecraft control and heavily demanding physics simulations. On the other hand, while working as amplifiers, the transistor can provide current and/or voltage gain by raising the strength of a weak signal. It accomplishes this by feeding more electricity into the system when correctly configured with forward and reverse biases. Amplifying transistors are useful for audio devices, transmitting and processing radio signals, and for fiber optic communications, all very important for the functioning of today's world. They have laid the foundation of modern electronics and allowed devices to get smaller and smaller. What used to take a machine the size of the car today can be accomplished by something that fits in your pocket, as this technology keeps progressing. According to Moore's law, transistor count on chips will double about every 2 years, so soon enough you will be able to fit an entire supercomputer inside your brain.